Welcome back to my new video. This video, we are going to be talking about network policies. So if you want to control traffic at the IP address or the port level, then you might want to consider using Kubernetes network policies for a particular applications in your cluster. So network policies allows you to specify how a pod is allowed to communicate with various network entities in your cluster. And network policies usually applies to connections with a pod on one or both ends. So if a port selector is empty, then the policy applies to all ports in that namespace. So if you declare or create any port or resource like deployment in your Kubernetes clusters, by default, all ports are able to communicate within each other by default without any restrictions. Okay, so a scenario where you create a network policies in two different namespaces, then the network policies applies to, let's say you have a backend and then a DB namespaces. So you create a backend application and then you have in the my backend namespace, and then you create two other resources, the two databases. The first one is the MySQL, and then the second one is the Redis database. And these two resources lives inside a DB namespace. So the policy that you want to create is to create that policy inside my backend namespace, because the backend resource is rather talking to the DB namespaces with those two resources in there. So you are free to always define Ingress or Egress policies in the same manifest file or YAML file. So as I said earlier on, by default, all traffic is allowed in all namespaces. So the policy types that we have is two. We have the Ingress and then the Egress. Okay, so this policy types are very critical. They determine how traffic is allowed to go out or to come in. Okay, so ingress technically means that traffic is coming into your network, and egress means traffic is leaving your network. So the egress is associated with to, and then the ingress is associated with from keywords. Okay, and there are four behaviors of these selectors. We have the port selector behavior, the namespace selector behavior, namespace selector and port selector behavior, or namespace selector or port selector behavior. So these are things that I'll explain in the next couple slides. So as you can see, I have so many diagrams on this slide. On the top left, we can see my SQL resource and then one backend resource. And as you can see, there's ingress traffic coming from the backend to the MySQL resource. And this is how you define it in your YAML file. So you read it this way: ingress from the port selector, and then it has to match some labels, and that label is called backend, okay, as declared over here. So traffic is coming from the backend to this port selector MySQL, okay, labeled as app:/MySQL. So this is how you read it: from the backend to the MySQL. Okay, and the policy type is what? Ingress, because traffic is coming from the backend to the MySQL. And you could create a new PHP MyAdmin resource or deployment. And once you create that, you should note that this MySQL won't be able to access the MySQL database running on port 3306 for the fact that you have declared or taint this MySQL resource as what? A network policy that allows only traffic from the back end. So what you need to do is to also create a policy for MySQL PHP MyAdmin resource so that it can get access to your database. And the diagram below it is a traffic going out from the backend to the MySQL running on port 3306, and then the Redis database on port 6379. So this is how you declare it in your manifest file. So I'm going to show you how you can read this whole thing. So you start from the top. So the traffic is coming from the back end, and the policy type is what? Egress, because traffic is going out. And then you specify your egress and then the properties under the egress. And then as you can see, egress is associated with to, and then ingress is associated with from. So traffic is coming from or leaving backend to the MySQL running on this port only, 3306. And then another traffic is coming to the Redis database from the backend to this specific port only, okay, which is 6379, the default port for Redis database. So as you can see, as I said earlier on, ingress is for traffic coming in, and then egress meaning traffic going out. And also the top right diagram, as you can see, we have three resources: coffee shop, payment processor, grocery store. They all been labeled. Okay, labeling is very important in Kubernetes. You label them so that your policy can actually use those labels to select the right port. Okay, so as you can see, traffic is going in and out of coffee shop and payment processor, but there's a limitation, or traffic is denied between grocery store and then the payment processor. Okay, so basically that is the idea here. So what we are going to do today is to design this architecture, network policy architecture here. So we have a name, we're going to create a namespace called app stack. And within that namespace, we're going to have three resources. The first one is the backend running on port 80, and then the front end running on port 80, and then MySQL DB running on port 3306. So as you can see, once you create these resources, automatically they're able to communicate among themselves. So you can, these three resources or ports can communicate. Backend can communicate with MySQL can communicate with backend, MySQL can communicate with front end can communicate with MySQL, and so forth. But we're going to leave traffic to flow between these two resources, that is backend and front end. And we are going to allow incoming traffic from the backend to the database. And then we are going to deny incoming traffic from the front end to the MySQL database. So that is the architecture. This is what we want to do. Okay, so the backend port can only send traffic to the MySQL database, and then the backend will feed the front end with whatever information it gets for the front end resource. But the front end cannot directly access your resource, you are going to deny traffic. So just to explain a little bit on the architectures, as before, there are some cases where you have the resources in different namespace. So let's say you have backend in the app namespace, and then my SQL and Redis also in the database namespace. So we want to do egress traffic, that is traffic leaving the backend to these two resources in a different namespace. So you read it this way: backend sending traffic, that is egress, to my SQL database, and then the namespace selector is what? Database. So you need to also specify the database. You see, they are all aligned on the same hierarchy. And then the target port you are considering is what? 3306. And then the other rule, which is the second rule, is the port selector, and it's going to select the Redis label. And then the namespace is also very important. So as you can see, we're going to specify the database, the namespace as database, and it's also filtering based on the target port, which is 6379. Okay, so this is how you declare this policy if the resources are living in different namespaces. Unlike the previous slide, we saw that all the resources were in the same namespace, so we didn't add the namespace selector. Okay, so you must just be very careful when defining this port selector and namespace selector. So if you want both conditions, port selector and namespace, this is how you define it. If you define it port selector or namespace by just adding the hyphen before the namespace selector, it means something different. It means that you either select the port selector or the namespace selector based on the namespace. But if you want both cases or both conditions, then you specify it this way. Okay, so these are some various ways of defining your network policy. So this is what, if you want to deny all ingress traffic, this is how you define it. If you want to deny all egress traffic, this is how you define it. And then allow all ingress traffic. So you see the ingress, meaning is empty bracket, so meaning everything. Then the policy type is ingress. The same applies to egress traffic. You see the egress, which is empty, meaning that allow every traffic to go out, and the policy type is what? Egress. And then you can also deny all egress, which I just said, and then deny all ingress and all egress traffic. So you see the port selector is open to all ports, and then the policy types is what? Ingress and then egress, meaning that you are denying all ingress and all egress traffic. And you can also target a range of ports. Okay, so this definition here is considering the default namespace. The port selector is what? To match DB label on the default namespace to communicate with any IP within the range 10.0.0.0/24 over the TCP, and provided that the target port is between 32,000 and 32,768. So this is an egress, so traffic leaving the DB to these target ports, okay, based on this IP address range. Okay, so we are just going to head towards a demo of this architecture. So I'm just going to switch back. Yeah, so as you can see, I have these deployments, and two of them is going to be a deployment, and one of them is going to be a pod. So as you can see, the kind is what a pod, and then it has these labels, tier database, and then it lives in the app stack namespace, and it's called what database, and then the container name is what database, and then the image is what MySQL. And then the other deployment is the backend. Okay, you know, we have three architecture: the backend, front end, and then the database. Okay, so the backend also has these labels, and then it's in the namespace app stack. It has two replicas, and then the image is what Nginx running on port 80, a container port 80. And then the other deployment is what is called what front end, lives in the app stack namespace, and then it has these labels, tier front end. And it also has two replica sets. And then the image is what Nginx running on container port 80. So we're also going to declare the network policy. So as I indicated before, this network policy is allowing incoming traffic from the back end. Okay, so traffic is coming, ingress traffic is coming from the back end to the database, okay, to the database. So as you can see, the policy types, we have two policy types, meaning that we are allowing traffic from the backend to the database, and then we are disallowing traffic from the front end. So basically that is what it means. And the incoming traffic to the database is allowed on port 3306 and no other port. So just this 3306 port that we are allowing traffic to our database. So you read it this way: traffic is coming from the backend to the database, and then we are disallowing traffic coming from the front end to our database. And the target port we are considering or allowing is 3306 on our database. And MySQL is actually running on 3306, so on TCP protocol. So basically that is it. So I'm just going to do a demo so that we can have some fun. So currently, let's check our running nodes. So we have two Kubernetes nodes that are running. So I'm going to create a namespace called create namespace called app-stack. You can call it whatever you want. I'm going to call it app stack. And then we're going to switch to this namespace. We're calling it app-stack. So what we're going to do here is we have our two files, the app stack and then the app stack network policy. So we're going to create the app stack first, which contains our resources. So we're going to say kubectl apply -f appstack.yaml. So one port created, and then two deployments, front end and back end. I'm going to deploy the other stack, which is the network. So what we can do is we can say kubectl get network policy. So as you can see, that this is the name of the network policy. and it has these port selectors, which is app to do, and then tier what database. We can also describe this network policy. So we're going to say describe network policy. We specify the name app stack -network -policy. So as you can see, this is how the network policy looks like, and it's allowing ingress traffic to this TCP port from the back end, and allowing egress traffic is none. And as you can see, selected ports are isolated for egress connectivity. And then you can see the policy types are what? Ingress and egress. Okay, so that is that. And we can also say get ports. So as you can see, we have two backend ports running, one database, a replica running, and then we have two front-end replicas running. So as you can see, these are the two IP addresses for the backend, the database, and then the two IP addresses for the front end. So I'm going to exec into the backend. So I'm going to say kubectl exec into and then I'm going to say --bin bash. So I'm going to exec into it. So I'm already in there. So I'm going to say apt update. Then I'm going to say apt install wget. So that is also installed. So what I'm going to do is I'm in the backend. So I want to check if I have access to the database. So the traffic coming from backend to the database, I want to check if that exists. So I'm going to copy the database IP address. So I'm going to say wget --, spider --, timeout is equal to 5 seconds, and then the IP address of the database. You see, if I hit enter, it says connecting to, and then connection is refused. Okay. So I'm going to exit again. I need space for the IP addresses. So now I'm going to check for the front end, which is this IP address. So communication between the front end and then the back end. So I'm going to say wget --, spider --, timeout is equal to 5 seconds, and then the IP address for the front end. You see, there was a connection. It says spider enable connecting to this IP address, and it's connected. And then the response is what? 200. Okay. Okay. So with our diagram, you saw that there was a communication between the front end and then the back end services. Okay. So let's check. Now we are in the back end, and then we check from back end to the database. So let me do that again. It's what 004. See, there's a connection that is refusing. And then let's also check from the database to the backend. So let's do that. So I'm going to say kubectl, we want to exec into the database and then see if there's a connection coming from the database to the backend. So I'm going to copy the command again. So now we are in the database, and then we want to check if we have a connection to the backend. And then the backend IP address, we can use this one, the first one, which is 1.6. Okay, it's a new database. So I'm going to say apt update. So let me copy the command first before I lose it. Update. I'm going to say apt install wget. So I'm going to run the command again. So you see that it's working. So it's connected, and then the response is 200. Okay. So we are able to communicate from the database. We are currently in the database pod, and then we are able to traffic between the database to the backend. Okay. So let's also check for the front end to the database. So I'm going to exec into the front end pod. kubectl exec. So I'm going to go inside front end pod, and then we'll be checking if we can communicate or send traffic from the front end to the database. And then the database IP address is this. Let me copy that. So we're going to say apt update, apt install wget. Okay, so that is that. So we're going to say wget --spider --timeout is equal to 5 seconds. And then we put in the IP address for the database. You see, there's a connection refuse response. So meaning that our network policy is working, because if you remember, we said we are not going to allow incoming traffic from the front end. Okay, so you can see clearly that there's no connection between these two resources, but we're able to connect from the backend to the database. And then we also checked if we could connect from the backend to the front end. And then you saw the response was also 200 status code. Okay, so basically that is that for this tutorial. So basically you can see that we're able to connect to from our database to the back end, and then that was okay, and then back end to the front end was also okay. But the front end to the database, we had an error that there was no connection established. So we deny incoming traffic from the front end. Yeah, so I think that is it. Don't forget to like and share this video. Don't forget also to subscribe, and I'll see you in the next one.